Hello and welcome to everyone. So yeah, I'm going to try and fire through some of the slides that we have fairly quickly so we can get onto some demos, which I hope is going to be illuminative for people's use of policy as code. Now, I know generally what people think about when they think about policy as code. They think about policies as being something that is very dry and a requirement and a very valid requirement for businesses. And I went and looked through, what do we think about when we think about password policies? And I thought about 8 different kinds of policies that we may be writing to do with just about a password that we're going to set. We're maybe going to have making sure that we have password history and minimum password age, maximum password age, password length, password complexity, password resetting, password auditing, password encryption, and none of this. For me, generally, when you're creating these kinds of policies, which I've done in the past, is something that you leap with joy at being able to do. So today, what I'm going to try and do is make policy fun, or at least make it slightly more automated, so that we don't have to keep these crazy documents that we have up to date. I'm Will Hall. My role in HeleCloud is as a management consultant in DevOps. That's a bit of a strange title for people who are just hearing of it. And really what that tries to mean is that I try to be able to upskill a whole range of people on using DevOps throughout the organization and be able to see where we can best apply DevOps style tools and theories to the ways of working that are operating. I'm also an implementation consultant for HashiCorp through our partnership with HashiCorp. I'm a GitLab hero, and we have a partnership with GitLab. I'm also a Docker community leader, and you can see my LinkedIn and my Twitter there as well, and a picture of my face that's very similar to the picture of my face on the webcam as well. And to keep my whistle wet, is that going to be, maybe that doesn't translate across the world, but so I'm having a drink this morning, and I'd love to know what you're having to drink as well. Boom. So I'm having coffee, and this is in a Druplicon mug. So Drupal is a content management system that I've had this cup for quite some time. So it seems that tea and water are popular options today. These are new polls that we're kind of running. I want to try and keep it interesting and varied for people. So I'm going to try and pop up a few polls as we go along today. Just to mention a little bit about HeleCloud as a company. So we are a premier consulting partner with AWS, providing all of these competencies and partner levels. We're pretty much 100% focused on working with AWS. We've got over 60 AWS certified engineers, and I think if you calculate the amount of certificates against the amount of people, I think we average out at 3 to 4 per person. That's helped by some people having 10 certificates, but we generally try and make sure that all of our engineers are AWS certified within their first 6 months of working with us. We've got project delivery capabilities, and pretty much we're kind of cloud born and bred, and so we've only really worked with the cloud in the past, and that has brought with it that we have a new capabilities for building software. We have various benefits, and trying to stay aligned with AWS practices, naturally contributing into those AWS practices around infrastructure as code, immutable infrastructure, and security and compliance is one of the important parts that we like to take forward with all the people we work with. Now, what we're going to be looking through today is about policy as code, and this is kind of a generalist overview of policy as code, and then we're going to look at some direct examples of using policy as code in infrastructure as code delivery, and we're going to look a bit at AWS, a bit at using Terraform and Open Policy Agent, and then a small amount at looking HashiCorp Vault and how that can be extended with Sentinel, and really about how you can extend the policy as code that you write. Many of these things are kind of because we're actually going to be looking at using code for many purposes. So we've got software and infrastructure, and we've got networking and our documentation, our CI/CD, our security is all able to be delivered as part of a codified entity. And that gives great values for people being able to actually build on top of what we're doing. And when we think about policy of code, we're really thinking about extending that as a new codified opportunity to bring all the values that we can repeatedly have for the code that we use. And it's kind of important to understand that as a generalist overview to get that value as codified policy. We have to be able to fulfill some requirements. So we need policies to set principles, rules, and guidelines for how we're going to work. And the idea of writing policy as code is just writing code to be able to manage and automate the application of these policies. It's no more complex or less complex than policy should be. And providing that you have the ability to understand how you're going to write a policy, we should be able to write that into code and deliver that over a platform. So I'm going to launch second poll already. So I'd love to know how many people have used policy as code and what they're using policy as code for. Can kind of come into the questions box as well if anyone has any questions. And I should say, if anyone does have any questions, then please try and fire them into the question and answer board, and I will answer them as we go along, hopefully. So when we think about the benefits of policy of code, we're really thinking about the benefits of code. Where code gives us automation, standardization, the ability to review and revision things. It gives us versioning and releasing. So we're able to transfer those policies that we're creating into realistic items that exist as elements of the overall IT landscape. And it gives a kind of structure to that security that we can build validation and auditability and compliance into what we're doing. And the tagline that I had for today's piece was about the continual compliance engineer. And what I'm trying to portray is that you are able to use this automation and policy as code together to ensure that you have continual compliance with how you're operating. And it's interesting that I've got that very few people have used policy as code. So this is going to be hopefully very instructive to you and also give people an idea of how they can work on things going forwards. Now, when we think about policy as code in AWS, we're generally thinking about kind of the management of access and integration of different parts of AWS. So hopefully most people are comfortable with AWS as a concept, and we have these services that we're going to connect together. We're going to generally do it via security groups or IAM policies, or we're going to use key policies, or we're going to have bucket policies, and these policies are then attached to the resources that we make to be able to give access or deny access or allow certain privileged aspects with regards to connecting and integrating with our AWS estate. And you can think kind of with IAM policies, they're defined as JSON items. They have a version statement. They're going to allow people to do specific actions to specific resources. This is an example of some Terraform that's been written into delivering a policy. And so you can see from the idea here, we have an idea of connecting people in these IAM policies. And whether you're going to centralize IAM policies, AWS will give you a whole range of default IAM policies, and then you can look at extending those to be able to give secure access to a specific subsection of your users or a subsection of your system. And you can think of kind of security policies as giving access for particular networking rules. This is an example of a security group policy that's giving access to port 22 from a specific CIDR, and then we're going to give access to bastions. So we've got policies that we already using. Policy as code is actually where we think of policy as code, and people have said that no, they're not using it. Well, pretty much if you're using AWS and you have IAM, you're using policy as code. You're just not necessarily thinking about that in an automated way of being able to test and deliver it. You're just thinking about it as part of the daily running of your systems, and that's fine. But actually we can start to extend it even further and be able to build those policies to encapsulate a lot more of what you're going to be working with. So a big chunk of the items I wanted to cover today was about policy as code in infrastructure as code, and it's going to be mainly using Terraform, because that's mainly the language I use for infrastructure as code. But it's going to be kind of bringing out the values through an example, and we can really start to understand where we're going with this policy as code concept. Now, when we think about policy as code in Terraform, we already know that Terraform is like a tool for building, changing, versioning infrastructure, and that the policy as code inside Terraform, if you are running Terraform Enterprise, is with Sentinel, and that there are other tools that you can use. But generally, I'm going to be looking at today at Terraform Compliance and an open policy agent, and running those in Terraform and how they operate. Now, the interesting thing for both of them is that actually the tools that we're now normally relying on being able to do policy as code on are being able to scan JSON that we're inputting and then make some specific actions on that JSON. So as we saw previously with our AWS tools, it's our policies for IAM are being defined in JSON, and then we could read those policies and make some decisions on them. So you could actually deploy Open Policy Agent as an example against AWS IAM rules if you wanted to, but that's kind of for a separate area if people wanted to look through that. So when we think about Terraform Compliance, I wanted to use Terraform Compliance as an early example because I think it's a relatively straightforward example. We have the idea of it's a lightweight framework for testing against Terraform, built in Python. It requires a plan to be able to run against, and it uses behavior-driven development and with a Cucumber syntax. And what I'll just kind of give a short overview to Terraform. You can look at some of the details here. We've got the project, and we've got the GitHub. There's a Docker hub for it, and I've made a specific container that's mainly for just running in CI tools. So as I quickly shift over to give an example of what a Terraform compliance job looks like, and if you've seen anything previously with viewing Cucumber based items, then it shouldn't be too foreign. So this is making sure that we have specific tags using Terraform Compliance, and we will then generate a plan running through our Terraform, and then make that plan into JSON, and then read through that plan with these specific rules. So this is using obviously Cucumber Gherkin syntax, and we have that we've got a feature. We've called it specific tags. The overall outline is that may make sure that tags are defined. We then look through the items when it has tags. We make sure that we check the value against tags and value. So the name, specific tags have to have the name, and the value can be anything, the owner can be anything, the project can be anything, and the environment has to be either prod, UAT, or dev, as an example for our tests in this option. And then we've kind of built out a series of tests that is going to say for every resource that supports tags that we're going to build in Terraform, we need to have these specific tags. If you don't have these specific tags, I am going to fail. And in failing, I will stop your CI from proceeding to the next level. Now, the real value that you get behind this is that we get to have things that start looking very similar to what we'd expect to be running, which is that we get our tools. This is in GitLab, and we're looking through our CI build here, and we can see that on the pipeline that's running with Terraform Compliance, we have failed the tests for what we've delivered. So we have run Terraform Compliance, we've loaded up our feature, and we can see that we've had failure because it doesn't have this bucket doesn't have a project property. This bucket doesn't have a project property. So we can see that we've got a failure on the items. They've got names, they've got owners, but we don't have properties. And we have a failure because they don't have proper environments being listed. And we can see at the end that we've got 2 failures. So this is going to stop our tools being able to deliver perfectly valid Terraform, but invalid according to the policies that we've set that we have to have specific tags running. Now, this is a really simple item, but it's also really valuable because, as we know, tags are I'm going to say the best way of being able to group together specific items to be able to provide reporting or control on viewing those specific items. So tags are ever present in the AWS that we deliver. Now, the kind of second level that I want to go for is that Terraform Compliance gives you a way of doing negative testing. So I could say, well, actually, my tests are failing in this. Well, what am I going to do? I can see that I've got failure that we haven't done project property, and I've got a failure that I haven't put the right environments in. So I could switch back into my my code, and looking through my projects, I could say, oh, well, I've not got the right items in here. I'm doing owner, and I've got a bucket name for what I'm doing, but I don't have a project, and I don't have an item that is set as I don't have a project, and I don't have the right environments, and I can see that they're not available in here. So I could come in and change my project so that actually when I go with names, environments, cost center, and owner, well, my environments, I'm going to set them all to what they can prod, UAT, and dev. So I will have to set them all to either prod, UAT, or dev. In my main, I'm going to say my environment is going to be dev, and this is dev, and this is going to be dev, and this is going to be prod. So that's fine. And then we will get back to the delivery of this, but when we push this commit, correct environment names. So I've just pushed that commit back up into my CI system, and we'll see shortly that that will then mean that our tests that were failing are going to pass. And so I've fulfilled that level of compliance. Even though my Terraform would perfectly well run, I'm now adding an extra level on top of what I want to run. So if we push this through to the next level, kind of Terraform Compliance is really nice to, really easy to read. We could imagine that these are relatively straightforward to be able to understand. And I want to push it forward though to the next level so that people can have an understanding of where they can go after Terraform Compliance. I realize that that's possibly a big jump, but the next level for kind of controlling these is imagining that we've got Open Policy Agent. Now, Open Policy Agent is a general purpose policy tool. So it's built in Go, and generally it's going to be a parser of JSON again. But where Open Policy Agent really starts to extend its use is that actually it's a high-level declarative language. So you have to write code to be able to investigate things with it, but you can then run against any of that JSON that you're running. So whether that JSON is running in Kubernetes or Envoy or Terraform or Kafka, or you want to try and investigate things in SQL or running things in Linux, there's examples for all of these on the Open Policy Agent website. And you'll then start to be able to investigate further and give greater nuance into the testing that you're going to do. So what I've got set up inside my code for running Open Policy Agent is that we've got the ability to input this package, and if you've used Sentinel, it's a relatively simple idea. And we've got this idea of having a blast radius. So the blast radius is going to accept how much damage we're going to accept with the items that we run. So our blast radius is going to be set to 50, and this is going to be important to remember when we look back at these shortly. So we're also going to say that we're going to have specific weights determined by what we've got. So if we're running an AWS S3 bucket as a Terraform resource, a delete is going to have a blast radius of 100. So actually, if we do a delete inside our plan, it's going to be over our blast radius of 50, so we're going to fail. Whereas a create is going to be just 10, and a modify is only going to be 1. So if we're just modifying our buckets, we could modify 50 buckets inside this item without breaking it, without going over the blast radius. And you can see that we've got policy documents as well that give us specific items. We can see that we're going to be only considering 2 different kinds of resource types. And we can say that our default is that authorization is false, and that we're going to be able to set a score And so if our scores are correct, we're going to return that we actually passed this as a test. And what this outputs at the end is going to be JSON that's investigated our Terraform JSON and given us a score overall of how we're applying to that blast radius. Now, the interesting thing you then get to do is we can start to say, well, actually, we want our changes to be small enough that they don't have a large impact to what we're doing. So maybe a delete is going to be worth 20 and a create is 10. So you can delete and create something inside the blast radius, but you can't change 5 buckets all in the same commit. And you can't change 100 buckets all in the same commit. You have to make smaller commits, and therefore you're having policy around the size of the workloads that you're adding, not just the size of the items that you look through. So when we go back into our browser, we get to see that Open Policy Agent, for example, in what we ran previously, is going to be showing that in actual fact it passed our previous items because our changes were not significant enough. We only had a score of 40 with the changes that we were running previously, and so we didn't override the examples, and this is a large output of everything from what we were outputting, and people should be able to just go and look at these if they wish to. So our changes are underneath the blast radius. Although we have changes, they are not so great a change that we're going to refuse to allow this to go through. So we're passing this as a test. And what that starts to add is some nuance to what you're doing. And you can imagine that because Open Policy Agent is available, we can see that Open Policy Agent is available for a whole range of different tools. By using it and understanding it as a high-level language to investigate JSON, we can actually, look at doing things inside Kubernetes. So we could look at how we're going to accept registry images, or we could look at how we're going to be allowing access through Envoy, or we could look at how we're going to be able to putting API things together for giving access to our web tokens. And so there's a whole range of other areas that we can start to think about with running Open Policy Agent, and even run it as a daemon to be able to run continually on what your operational methods are going to be. And that's really where we start to see the additional value that Open Policy Agent gives, is that it becomes a high-level language to be able to control policy as code. So whereas Terraform Compliance is really, it's only going to work against Terraform, and it's easy to use, but with that ease you get a limited feature set. With Open Policy Agent, you get to be able to extend that feature set even further. So as I kind of move on, we've gone through our demo time, and you can come back to that project and have a look through some items that have changed in that. You can also think about there's other tools for being able to do this, and one tool that I wanted to pull out was HeleCloud Vault. So Vault works in a similar way to giving API access. So it's not going to be investigating JSON, it's going to be doing API access. And when we imagine that we kind of have a way that Vault operates, where we have at the top of the triangle, we've got humans or machines being able to access different authentication models, and then policies that give access to secret engines. And so our policy as code in Vault is defined as a way of being able to give specific rules for being able to access parts of the API. So this would be giving access to different parts of Vault's API, or giving denying parts of access to Vault's API. And I wanted to give that as a different example, because these are what I think the main two policy as code tools that people are going to use. You're going to need some kind of secrets engines, and you're going to need some way of being able to investigate how you're doing generally JSON. So we can look at Open Policy Agent, but if you're using Terraform Compliance is a really good way of being able to get that up and running, and being able to apply those tests on your Terraform estate as well. And so what I'm hoping to see is that what we've seen is that policy as code is a really useful way of being able to control the delivery of infrastructure and tools within your overall IT estate. It's going to give you all the benefits of code. It's going to give you automation, standardization, the ability to review and revision your rules. And it's going to give you versioning and releasing of what you have, and being able to control not only the negative aspects, but also the some aspects with regards to the blast radius of the delivery of items that you're doing. And you can have that continual enforcement of policy. So you've seen an example of where I'm running things through GitLab CI. I'm failing the tests if you don't fulfill the objectives of my policy. You're written fine Terraform, but it's too big a change, or it's changing things that I don't want you to be allowed to change, or you don't have the correct items run in there. So we're seeing a continual enforcement of that policy. And that drives us towards having a DevSecOps operational method where we're embedding security into our DevOps processes. We have security as part of the continual process of delivery, not as a separate item or as something that's thought about as a checkbox. So I'm kind of launching my last poll because I'm really interested in whether people have seen this and think that this serves as a really good example of policy as code, and whether they think that it's going to be applicable to them. I have some white papers that HeleCloud have worked on previously about using infrastructure as code with code build, Terraform, and inspec, which is another kind of compliance as code tool. And then we have some items about building secured immutable infrastructure with AWS. And lastly, for people who are viewing this from the recording, we're trying to make these things available through our YouTube channel, so you can like or subscribe or comment or share. And if anyone has any questions, then I'd love to be able to answer them for you, be it now or be